The Incredible History of Computers from Ancient Counting to AI. Imagine waking up tomorrow and discovering that every computer on Earth has disappeared. No smartphones, no Google, no video games, no streaming, no social media. Even your car might not start. It sounds like science fiction, but the technology behind the modern computer has a surprisingly long history. And it didn't begin in Silicon Valley. It didn't even begin with electricity. The story of the computer begins thousands of years ago, when humans first looked at a pile of objects and thought, there has to be a faster way to count all of this. So how did we go from counting stones to machines that can talk, create art, write code, and even imitate human reasoning? Let's take a journey through the incredible history of the computer. Before computers, the need to count. Long before electricity, people needed to keep track of things. Farmers counted animals, merchants counted goods and money, governments counted taxes and populations, and as civilizations became larger, simple counting became more difficult. One of the earliest solutions was the abacus. The abacus used beads, or stones, that could be moved along rods to represent numbers. It was simple, but incredibly useful. And here's an important point. An abacus wasn't actually a computer. It didn't think. It didn't calculate by itself. A human had to move the beads and perform the operations. But the basic idea was revolutionary. A machine could help a human process information. That idea would eventually lead to something much more powerful. The first mechanical calculators. Fast forward thousands of years. By the 1600s, mathematicians and scientists were dealing with increasingly complicated calculations. In 1642, a young French mathematician named Blaise Pascal built a mechanical calculating machine. It became known as the Pascaline. The machine used gears and wheels to perform addition and subtraction. It was an impressive invention. But the real breakthrough came about 2 centuries later. In the 1800s, an English mathematician and inventor named Charles Babbage imagined something far more ambitious. He wanted to build a machine that could perform calculations automatically. He called one of his designs the difference engine. But Babbage didn't stop there. He designed something even more advanced, the analytical engine. It was never fully completed during his lifetime, but the concept was astonishingly similar to a modern computer. It had a form of memory, it had a processing unit, and it could follow instructions. In other words, Babbage was imagining a programmable computer, long before electronic computers existed. The world's first programmer. And this is where another fascinating character enters the story. Her name was Ada Lovelace. Ada was an English mathematician who studied Babbage's analytical engine. She realized that the machine could potentially do much more than simple arithmetic. It could follow a sequence of instructions. She even wrote a detailed algorithm intended for the analytical engine. Because of this, Ada Lovelace is widely recognized as the world's first computer programmer. And she had another remarkable insight. She suggested that machines might eventually manipulate things other than numbers, potentially even music or symbols. Remember, this was in the 1840s, more than a century before modern computers existed. In a sense, Ada Lovelace was imagining the future. When computers learned to process information. By the late 1800s, another problem appeared. Governments were collecting enormous amounts of information. In the United States, the 1880 census took years to process. So an American inventor named Herman Hollerith developed a machine that used punched cards to store and process information. Instead of manually processing every piece of information, the machine could read patterns in the cards and quickly organize the data. The system was a huge success, and Hollerith's company eventually became part of something much bigger, a company that would become famous around the world, IBM. The computer industry was beginning to take shape, but the machines were still mechanical. The next revolution would come from electricity. The birth of the electronic computer. During World War II, the demand for fast calculations exploded. Scientists and engineers needed to calculate artillery trajectories, analyze data, break codes, and solve complex mathematical problems. Mechanical machines simply weren't fast enough, so engineers began building electronic computers. One of the most famous was ENIAC, completed in the United States in 1945. ENIAC was enormous. It weighed around 30 tons, it filled a large room, and it contained thousands of vacuum tubes. Compared with a modern smartphone, ENIAC was incredibly primitive, but it had one extraordinary advantage. It was electronic. Instead of relying on slowly moving mechanical parts, it could perform calculations using electronic signals, and it was dramatically faster than earlier machines. The age of electronic computing had begun. But there was a problem. Vacuum tubes were large, fragile, and consumed enormous amounts of electricity. Engineers needed something smaller, something more reliable. And in 1947, they found it. The tiny invention that changed everything. At Bell Labs, 3 scientists, John Bardeen, Walter Brattain, and William Shockley, helped develop the first practical transistor. The transistor could perform many of the functions of a vacuum tube, but it was dramatically smaller. It required less power. And it was much more reliable. The transistor became one of the most important inventions in modern history. It made smaller computers possible. Then came integrated circuits. Instead of building electronic components one by one, engineers could place many components onto a tiny piece of material. And eventually, an entire central processing unit could fit onto a single chip. The microprocessor had arrived. Now the computer could finally become personal. From giant machines to personal computers. For decades, computers were enormous and extremely expensive. They belonged to governments, universities, research laboratories, and large corporations. But in the 1970s, things started to change. Microprocessors became cheaper and more powerful. Hobbyists began building their own computers. Then came machines such as the Apple II, introduced in 1977. And in 1981, IBM introduced the IBM Personal Computer, better known simply as the IBM PC. Computers were no longer just machines for scientists. They were becoming tools for ordinary people. People could write documents, create spreadsheets, play games, and store information. The computer was moving from the laboratory into the home. And then another revolution happened. Computers started talking to each other. The internet changes everything. Imagine having a powerful computer, but having no way to communicate with another computer. That was the world before computer networking became widespread. One important early network was ARPANET, launched in 1969. It connected computers at research institutions and helped establish ideas that would eventually influence the modern internet. Then, in the early 1990s, the World Wide Web made the internet much easier for ordinary people to use. Suddenly, information from around the world could be accessed from a computer screen. Email became normal. Websites appeared. Online shopping emerged. And the computer was no longer just a calculator or a word processor. It became a gateway to a global network. The computer in your pocket. Then came the smartphone era. A device that could fit in your pocket could now perform tasks that once required an entire room full of computers. You could take photographs, watch movies, use GPS, send messages, browse the web, make video calls, and carry millions of times more computing power than some of the earliest computers ever built. But the story didn't stop there. The next transformation was already beginning: artificial intelligence. From computers that calculate to computers that create. Traditional computers were designed to follow instructions, but modern AI systems can do something that feels very different. They can recognize patterns, understand human language, analyze images, generate text, create pictures, write computer code, translate between languages, and interact with people through conversation. In just a few hundred years, humanity went from mechanical gears to machines capable of processing enormous amounts of information in seconds. And here's the most fascinating part. We're still in the middle of the story. The computer has evolved from a tool for counting into a machine for processing information, into a global communication device, and now into something that can assist with creativity, research, and decision-making. Final thoughts. So, what is the history of the computer really about? It's not just the story of machines. It's the story of a very human desire to extend what our minds and bodies can do. We invented the abacus because we wanted to count faster. We built mechanical calculators because we wanted more accurate calculations. We created electronic computers because we wanted more speed. We connected computers because we wanted to share information. And now we're developing artificial intelligence because we want machines to work with us in entirely new ways. From a handful of beads on an ancient abacus, to a supercomputer processing billions of operations, to an AI assistant sitting inside your phone, the journey is almost unbelievable. And the biggest question isn't where computers came from, it's where will they take us next? Because if the last 100 years have taught us anything, it's that the future of computing may be far stranger and far more exciting than we can imagine.